Hello everyone, my name is Hritik Saini and today I am going to present on the topic 8085 microprocessor, operations and its architecture. Let's first discuss what is microprocessor. Microprocessor is a programmable device which uses numbers as its input and perform arithmetic and logical operations on them according to the program present in the memory and then return another set of numbers as a result. Generally, microprocessor is made up of three main units: the arithmetic logical unit (ALU), the control unit, and the array of register for holding the value of data. Now, let us discuss the architecture of 8085. It uses three separate buses to perform its operations. First, the address bus, second, the data bus, and third, the control bus. The address bus. It is a 16-bit wide A0 to A15. Therefore, the 8085 can access location with numbers from 0 to 65536. The 8085 can access a total of 64K addresses. It is unidirectional in nature, means information flows out of the microprocessor and into the memory or peripherals. When 8085 wanted to access a peripheral or a memory location, it places the 16-bit address on the address bus and then send the appropriate control signal. The data bus. It is 8-bit wide, D0 to D7. It is bidirectional in nature, means information flows both way between the microprocessor and the memory or input-output devices connecting to the microprocessor. The 8085 uses the data bus to transfer the binary information. Since the data bus has 8 bits only, then the 8085 can manipulate data 8 bits at a time only. Next, we have control bus. There is no real control bus. Instead, the control bus is made up of number of single bits control signals. Then we have this diagram showing 8085 microprocessor unit, memories, input, output, address buses, data buses, and control buses. Now, the microprocessor can be programmed to perform function on a given data by writing a specific instruction into this memory. The microprocessor reads one instruction at a time, matches it with this instruction set, and performs the data manipulation specified. The result is either stored back into the memory or displayed on an output device connecting to the microprocessor. Then we have three different type of operations in a microprocessor. First, microprocessor initiated operations, internal operations, peripheral initiated operations. Then we have to discuss the communication process between the microprocessor and peripheral devices. Microprocessor treats memory and input-output devices the same way. For example, the keyboard may look like memory address A3F2H. To get what key is pressed, the microprocessor simply reads the data at the location A3F2H. The communication process between microprocessor and peripheral devices consists of following three steps. Identify the address. Second, transfer the binary information using the data bus and then provide the right timing signals. Now we have the read operation. For read operation, microprocessor places the 16-bit of memory location on the address bus. Then the microprocessor activates the control signal called memory read, which enables the memory chip. Then memory decodes the address and identifies the right location. Then memory places the content on the data bus and microprocessor reads the value of the data bus after a certain amount of time. Internal data operations. 8085 can perform a number of internal operations such as storing data, arithmetic and logical operations, testing for conditions, and etc. To perform this operation, the microprocessor needed an internal architecture similar to the following, in which we have accumulator, status registers, general purpose register, stack pointers, program counter PC. The accumulator, it is the 8-bit purpose register which is connecting to ALU, temporary registers. All of the arithmetic and logic operations are done in the temporary register by user can't access it. It is a group of 5 flip-flops used to know status of various operations done. The flag register along with the accumulator is called the program status word PSW. The flag register is given by S. Sign flag is set when result of an operation is negative. Zero flag is set when result of an operation is zero. Auxiliary flag is set when there is carry out of lower nibble or lower 4 bits of the operations. Carry flag is set when there is carry generated by an operation, and parity flag is set when result contain even number of ones. Rest are don't care flip-flops. Here is a given diagram in flag registers of 8085. Next, we have program counter. This is a register that is used to control the sequencing of the execution of an instruction. The register always holds the next address of the instruction, and since it holds an address, it must be a 16-bit wide. Next, we have the stack pointer. The stack pointer is also a 16-bit register that is used to point into the memory. The memory this register point is a special area called stack. The stack is usually accessed in last in first out fashion, means the last element enter comes out first. Next, we have the externally initiated operations. External devices can initiate one of the following 4 operations. We have reset. All the operations are stopped and the program counter is reset to 0000. And then we have interrupt. The microprocessor operations are interrupted and the microprocessor execute what is called a service routine. This routine handles the interrupt, then the microprocessor returns to its previous operations and continues. Ready. The 8085 has a pin called ready. The pin is used by external devices to stop the 8085 until they catch up. As long as ready pin is low, the 8085 will be in a wait state. We have hold. The 8085 has a pin called hold. The pin is used by external devices to gain control of the buses. When hold signal is activated by an external device, the 8085 stop executing instructions and stop using the buses. This will allow external devices to control the information on the buses. Example, dynamic memory access, DMA. Next, we have memory in a microprocessor and its operations. Memory in a microprocessor system is where information is kept. It can be classified into 2 main types: main memory, storage memory. Memory consists RAM and ROM. Storage memory consists disk, CD-ROMs, etc. RAM is made up of registers that are made up of flip-flops or memory element. ROM, read-only memory, uses diodes instead of flip-flops to permanently hold the information. For the microprocessor to access read or write information in the memory, RAM or ROM, it needs to do the following. Select the right memory chip using part of the address buses, identify the memory location, and then access the data using the data buses. To design an operation of a memory, to execute a program, the user enters its information in binary format into the memory. The microprocessor then reads this instruction and whatever the data is needed from memory, executes the instruction and places the result either in memory or produce it on an output device. Generally, memory uses 3 cycle instruction. The microprocessor fetches each instruction, decodes it, and then executes it. This sequence is continued until all the instructions are performed. So, this is all we have for microprocessor operations and its architecture. Thank you.